Hey guys, today we are talking about parabolas, but we're not talking about parabolas in the sense that we used to. We're going to be talking about them in regards to being a conic section. So the definition of a parabola is any point on that parabola is at an equal distance from some fixed point that we're going to call the focus and a fixed straight line, which we're going to call the directrix. And this picture is kind of going through it. So if you notice, this blue line is always the same length as that orange line. And that's how that parabola gets made. The directrix is a straight line, and this focus is just a point. Okay, and so let's talk about some of our equations and how we would graph them. Okay, the first type of equation is going to look pretty similar to stuff that we've seen. This is a parabola that has a vertical axis. So basically, it's the parabolas that you're used to seeing that look like this. Well, I'm going to erase that because that was pretty terrible. So it's got just that straight up and down, or it could go up, or it could open up, or it could open down. Okay, so if you notice here on a vertical axis parabola, the x term is squared, and there's some sort of numbers that are happening in front of my y term. Okay, so the first thing I need to know about this equation is that the vertex is going to be kind of what we were calling the center before on these graphs. So the center before was my h comma k. That's just now my vertex. So this is going to be my center or my vertex, whichever one you want to call it. So my vertex on this would be h comma k. So if there's nothing being added or subtracted, it's just at the origin. Now my focus is going to be inside my parabola. My focus is always inside the parabola. So since this one opens up, this is going to be my focus. Okay, that line that we draw is always on the outside of the parabola. And so there's going to be this line right here that will be my directrix. And the distance from your center to your focus, or from your center to your directrix, is always going to be the length c. It's that focal length that we were talking about when we were doing ellipses. So with that, we know that my focus then is always going to be c units away from my vertex. So if I was to denote this in a vertical axis parabola, my x is going to stay the same, and then I'm going to add my c value. So I'm going to go up that many to find that focus point. Okay, the directrix, if you notice on this, my directrix is that horizontal line. And how I show a horizontal line is going to be a hoivux, so it'll always be a y equals for a vertical axis parabola. So I have my directrix as a y equals line, and that y equals line is again going to be your y coordinate, but now I'm going to subtract c. Okay, and finally my axis of symmetry, that's something that you've seen for a while now. That axis of symmetry goes through your vertex and is that straight vertical line in this case. So I could fold it over this line and it would be the same graph on either side. So my axis of symmetry is going to be a vertical line, so it'll be an x equals, and it's just the x coordinate. Now please do note, you could have a negative c value. So if I have a positive c value, my graph opens up. So it looks like this guy over here. But if I had a negative c value, my graph would open down, and then this would look a little different because adding a negative c is going to be like subtracting, and subtracting a negative c is going to be like adding. So if you end up getting a negative here, all that's going to change is your graph will open down instead of opening up. Okay, so now we're going to look at that graph that we haven't really seen before, because this graph isn't a function, so you haven't really talked about it in any math class before. So if you notice, it's going to have a very similar equation. It's just now my y is squared. So it's saying I can plug in that x and get two separate y values because it could be negative or positive. So when I look here, that's what this graph is going to look like. Again, you could have a positive c or a negative c. If you have a positive c value, you're going to open to the right, and it's going to look like that c, the letter c. Okay, if you have a negative c, it's going to open to the left, and then it'll look like that. Okay, so the equation is going to work out pretty much the same. Your vertex, again, is kind of like your center, is h comma k. And on the little thing that's different on this is, if you notice, your focus is always going to be on the inside of your parabola. And so now the inside of my parabola is over here. So instead of adding to the y value, I'm going to add to the x value. So on this one, let me use purple, it's going to be h plus C, sorry, comma K. Okay, okay. So then my directrix, if you notice on this one, is actually a vertical line now because it's on the other side of my focus. And so again, a vertical line has an x equals equation, Voivux, and that's going to be found using H minus C. Finally, your axis of symmetry is going through the middle of your parabola through that vertex. And so here you notice it would be a horizontal line. So I would need to fold it over a y equals line. And so y equals k in this case. And I don't think that it's super important to like memorize these types of facts. A lot of times if you start to graph your equation, you're going to see that it makes sense where the focus is, and you can just count out your C value and just plot the point that way. So let's do some examples to kind of get us used to this new form of a parabola. Okay, so here is my beautiful parabola, and I need to learn about a lot of pieces of it. And again, a lot of times it's going to be the easiest if you can get a graph of it and then name points. So the first thing that I know and I need to have is that my squared term is over here, and then the constant term, the number, is with the not squared thing. Okay, so this is good. This is in standard form. I'm happy. If I look at it too, it's going to be a vertical parabola because this is what I'm used to seeing. I'm used to seeing an x squared. So this is going to be a vertical parabola. It's going to open up or down. And since this is a positive number here, we know that it's going to open up. So it's going to be just like we were used to. It's just a couple different things we got to look at. Okay, so my vertex is again going to be with my x and my y coordinates. So with x, I have -2, because remember you changed the sign here. And then I'd have 3 as my vertex. Okay, so I'm going to go ahead and plot that point on a grid. Oh boy, oh boy. Okay, and so here's my vertex. That's going to be the bottom of my parabola. Okay, now I have to find my value of C. Remember, this graph is going to open up. That's not a very good approximation. We'll fix it in a second. But to find my value of C, I'm going to take my constant term, which in this case is 8. And if you notice in the equation, it always has 4 times C. 4 is just built in. So I'm going to take whatever my constant number is and divide it by 4. And that's going to get me +2. So I know that my focus and my directrix are 2 away from that vertex. And because it's vertical, my focus is going to be 2 up, and my directrix is going to be 2 down. So 1, 2 is actually on the axis. So if I want to name that point for my focus, I can see it's on the same x line, -2, sorry. And then I went up 2 more. So instead of being at 3, it'll be 3 plus 2, or 5. And again, you can just count that. I can see I put 5 little tick marks on there. My focus is inside my parabola. My directrix is, again, because this is a vertical parabola, it's going to be a y equals line because it's a horizontal line. And that's just happening at 1. Apparently I can't count. That's not actually on the axis. I should be shamed right now, because if I count down 1, 2, that's at 1. So y equals 1. So I just had subtracted that from my y value. Okay, so there's my picture. I can always plug in points. A lot of times I'll plug in 0 to find that intercept to kind of get an idea of what the shape of the graph is. But finding the axis of symmetry, again, since this is a regular vertical parabola, that axis of symmetry goes right through here, through my vertex, and that would just be at x equals -2. Okay, now finding the domain and range, that's something you've been doing since Algebra 2. You know here that I could plug in any x value, so my domain goes from -infinity to infinity, or I could write all real numbers, whereas my range, the lowest y value I could possibly get is actually the y value of my vertex. So that would be 3 to infinity. Remember, we could equal to 3. Now if my parabola faced down, it would look a little different. It would be -infinity up to that vertex. But here's the picture of my regular parabola. Let's look at one that is not a regular parabola. So we have this guy. Now the thing that I'm worried about here is this parabola is not actually in standard form. I don't have it looking like what I want to have it look like. So I'm going to go ahead and subtract 3 from both sides. And now I have 1/12 y minus 1 squared equals x minus 3. Now the one thing you have to remember is that your number, your whatever little number thing, goes in front of the not squared term. So I've got to move this 1/12 over to the other side. And I'm going to do that by timesing both sides by 12. I'm not going to do any distribution. I'm just going to leave it as 12 times x minus 3 because now this is in standard form and I can pick those important pieces out of it. So the first thing I notice about it, since it has y squared, that means it's not a function. This is going to be a horizontal graph. And because my c is positive, that means it's going to open to the right. Again, when I'm looking for my vertex, I want to use my x-coordinate that goes with x, so that'll be 3, and flip the signs. So 3, 1 is my vertex. And to find my value of c, I take this number right here and I divide it by 4. So I find that my value of c is 3. So I'm going to go ahead and plot this. 1, 2, 3, 1. So here's my vertex. And remember, it's opening out to the right. So if I'm looking for my focus is going to be inside my parabola. So I'm going to go 3 to the right. So that point is at 6, 1. Okay, it's going to be along that axis of symmetry, but it's over. Okay, now I'm going to go look at my directrix, and it goes 3 the opposite direction. So it's going to go 1, 2. Hey, look, I'm actually on the axis this time. And it's, again, this one's a vertical line because this guy is opening out. Okay, so I'm looking here. This is going to be at a vertical line is an x equals, and that's at x equals 0. So that's how I find my vertex and my directrix. Then I look at my axis of symmetry. Again, my axis of symmetry is the on this one, it's going to be the y coordinate of my vertex. That's where I could fold my graph over. And then if I look here, my domain is no longer all real numbers. My domain, my x value, starts here at positive 3 and then goes on to infinity. However, my y values, those are the ones that can go forever and ever. So I can pick any number for my range on these graphs. Okay, now if they give you, for instance, words, where I'm going to reflect over some axes and translate 3 units left and 7 units up, you can always sketch a picture. Now you know here that I'm going to take this graph and I'm going to change it somehow. So if I'm translating left, remember, anything that happens inside your x parentheses are liars. So when I look here, I'm going to add 3 instead of subtracting. I think that it's subtracting, so I'm going to add. Okay, now the weird thing about these is now anything inside the parenthesis, the y is also going to be a liar. So since I want to move it up, I'm going to go ahead and leave it as that negative sign. Okay, and the last thing that I needed to do is reflect it over the y-axis, which means I need to change this number in the front. So this would get me that graph that's reflected over the y-axis and translated 3 units left and 7 units up. I've changed my vertex and I've changed the orientation of the graph. The last thing they might ask you to do is look at a picture and write the equation. So for this one, of course, I'm going to look and see what the orientation of my parabola is. This is going to be a vertical parabola, which I know means that my x-coordinate needs to be squared, and my y-coordinate is just going to be normal. Okay, now I'm going to look for my vertex. My vertex in this case, and hopefully you can see this better on your picture, is at 3, negative 2. So I'm going to go ahead and plug that into my formula. So I'm going to have minus 3 and then minus a negative 2. And now at this point, I need to find that c value. So when I look here, remember my vertex is always c units away from my focus or c units away from my directrix. So this, if you look, is just 1 unit as well as this way. It's just 1 unit, which means that my c value is going to equal 1. Be careful here though. You know that your equation will always have a 4 stuck in it. Okay, so there's always going to be a 4. And we're timesing it by 1. Now the one thing to notice though, since this opens down, that makes my c value a negative 1. So when I look here, I have to make sure that that's negative. So my final equation is going to look like this. Okay, so again, if you have a negative c value, your graph opens opposite of what you think it's going to open. That's all I've got. Hope you have a great evening.